How many ways can this be done if, a bunch of conditions here. First one is Annan doesn't arrive until 11 and is busy from 2 to 3. Edwards is available 12 noon or later. Good is available until 2 p.m. Jamshidian is available from 11 to 3. And Solheim is available from 10 to 12 and 2 to 3. Okay. Over here. Everybody understand that question? I'm going to give you the same 30 seconds I gave you before. I want you to quietly think about it for a minute as to what topic this has to do with and what method you use, and then we'll take a volunteer to lead us onward. You have a question?
Yeah.
What's that?
For the like project for the
It would take. So it works.
Yeah.
So my question is, does it always work? I don't actually know. So that would be if it was. That would be for you to play with a little bit. See if you could create an example where it wasn't so nice. My guess is you will be able to create an example where that doesn't work. Okay, how many people think they know what topic this has to do with? Jason, what do you think?
forbidden position.
Okay, good. Forbidden positions, right. We're trying to figure out the number of ways to schedule these 5 people into basically 5 one-hour slots. So what I can do is draw my forbidden positions, and now I do have rows and columns. Okay, so let me do this. Okay, I'm going to put my professors on the different rows. So A, E, G, J, and S. Those are going to be the 5 rows. And then my time slots are going to be 10 a.m., 11 a.m., 12, 1, and 2. Okay, so the way you would draw this would be, Davey, you might not want to sit there. I've got a camera set up in the back. You could just grab another chair. Thanks. So Annan doesn't arrive until 11 and is busy from 2 to 3. So what would I do here? Adrian?
Place an X.
X is where?
2 o'clock.
Okay, up here, right?
Yeah.
And what else? Yeah, I don't arrive until 11, so you put an X there too. Okay? All right, where else do I have X's? And the second one. Okay, good. What about for the third one? He is available until 2, so that means he's just not available there. Okay? The fourth one? He is available from 11 to 3, so I just put one X there, right? And then Solheim is available from 10 to 12, and from 2 to 3, put back here. Okay. By the way, when we graded the first midterm for this class, I had to, it was a nightmare as it turned out. There was a forbidden positions problem. The thing that made it a nightmare was that you can actually set this up as columns instead of rows, okay? And if you do that, of course you get the same answer. But depending on how many x's are, where the x's are positioned, it makes a big difference in how hard it is to calculate those r's. You remember the R1, R2, R3, R4, and so on? So if you had flipped this over and put the professors on the top and the time slots down this way, it would not be wrong, but you might find that it's a pain to calculate the R values. So the R values won't necessarily be the same if you do rows versus columns, but at the end of the calculation, they have to all mathematically work out to the same final answer. But with the addition and subtraction that goes on, it can be a mess. So it's, just so you know, that's not something you're going to necessarily recognize right off the top. Is it better to do it this way, or would it have been better to do it the other way? It's maybe not clear. This is a pretty favorable way to have it set up, though, because no row has more than 2 x's in it. If we had done the columns this way, then there'd be this 10 o'clock column would have had there's 3 x's, so it's just a little bit harder. If you don't have very many x's in the rows, it's a little easier. So the x's are spread out in a more simple way to analyze the problem. So I'm actually happy with it this way, but all I want to say is it's okay if you switch rows and columns. It's okay, but you will get different values of R, the R1, R2, R3, R4, R5 as you go along. Okay, so we have to remember how this whole thing works. Oh.
I have a question.
Yeah.
With the last one, from 10 to 12 and from 2 to 3, do we not have to have
Oh.
an X in the 12?
Oh, I'm sorry. I'm sorry. That's my mistake. Yeah. Just seeing if you guys are awake. Right. Not available from 12 to 1. Yeah. Or from 1 to 2. Okay, that's better. Okay, was that your point? Okay, great. Thanks. Okay, so basically we want to assign every professor to a 1-hour slot. And the open gaps are where we can do that. So, one way to do it would be, I don't know, something like this. I'm just making up an example so we could have, that would be a valid way to solve the problem. Okay, there'll be lots of others. Okay, and we basically treat this like inclusion exclusion. So if there were no constraints, whatsoever, you would have 5 factorial ways to do this. The idea is that you're going to put one blue dot in every row and column. So in the first row you have 5 choices. In the next row you will only have 4 choices. The next row 3 choices, 2, and then 1, because you don't want to use the same column more than once. So this is with no restrictions. And then from there, what you're doing is you're subtracting violations. So you subtract violations, and there are sort of 5 types of violations. You can violate Annan's schedule, you can violate Solheid's schedule, you can violate each professor, you can violate their schedule. So if you remember, basically what you do is, so for example, violations to Annan's schedule, you've got 2 x's, right? So there's 2 ways to make a mistake there. And then you don't worry about, in the remaining 4 rows, you have 4 more slots to fill in, so that's just a 4 factorial. You don't worry about any violations in those positions. So there's a 4 factorial coming from that. But of course, violating Annan's schedule is only one way to have 1 violation. You could also violate Edward's schedule or Good's schedule or whatever. So you actually just add up the number of x's. If you remember, we called that R1. R1 is simply the total number of x's, and in this case that is 8, right? So there's 8 of those. So there's 8 one-way violations, okay? Then what we have to do is we realized by inclusion-exclusion that we double subtracted things, so we have to go back and add in the 2-way violations. Now, since there are 5 rows here, there will be how many yeah, 5 choose 2, which is 10, right? So we look at, for example, Anna and Edwards. How many ways are there to make a violation in both of those two rows? Well, if you pick this X, you of course wouldn't have picked this X because you can't pick them in the same column. So it would be this X with this X, that's 1. Or you could pick this X with either of these two, so 2, 3. So there'd be 3 of those, right? So this is what we call R2, is 3. And this is sort of this is the Anna and Edwards term. And then you have, the next one is going to be the Anna and Good term. So how many ways are there to have a violation in the first and third row? Only one, right? Why is it a good idea to show all of your work here? Well, because you're going to be adding up 10 numbers. If you get one of them wrong, right, then the whole value would be wrong, and if you don't have any work to show for it, I can't give you any partial credit. So if you show out all the terms, I can be kind of generous, and in fact, usually if you just screw up one of the numbers somewhere along the line, I usually don't even worry about it. So then we have the A and J term. It's also a 1. And then we have the A and S term, which would be, how many? 4 of them, right? 2 choices in the first. See, the X's on the first row and last row are in different columns. So you have 4 choices there. Okay? Then you have the EG term. What's EG? What's the EG term? 2. Okay? Then you have the EJ term. What's that going to equal? 1. And then the ES term. And that's 4. Good. Okay? And then GJ. The GJ term has how many choices? Just 1, right? Alright, I got a couple more. I'll put them up here. I've got to do the GS term. How many of those are there? 2 of them, okay. And then the JS term, how many of those are there? 2, right? So you just take that and you add the whole thing up, and you get what? 21? I think it's 21. Okay. All right, I think maybe we should do a little bit more. This is a kind of a routine thing, but I just want to make sure everybody remembers how to do this correctly. So, the next one would be the 3-way intersections, and these would be added back in. Okay, so again, what we're going to do here is we're going to have 21 times 3 factorial. And now I have to subtract the next one, which is R3 times 2 factorial. So R3, I'm going to have how many terms for this one? 5 choose 3, right? 5 choose 3 is equal to what? 10. It's 10. 5 choose 3, of course, is the same as 5 choose 2. So however many terms that we just wrote down, we have to write down that many terms again. Okay, so let's see. We're going to have AEG. I'm just going to write down all of the combinations first. So AEG, AEJ, AES. Then we'll have AGJ, AGS, AJS. And then EGJ, EGS, EJS, and then GJS. That should be 10 different things. And we just have to work these out. Okay, let's see if we can do it fairly quickly. The AEG scenario. How many ways are there to put X's in the first 3 rows? There's only 1, right? Because you must use this X, which means you can't use this X, so you must use this X, which means you can't use this X, which means you must use that one. So there's only one way to violate all 3 of those rows. Okay? How about the AEJ term? How many of those will there be? 1. Again, there's just 1. You guys get that? Yeah, okay. AES, let me see. Rocky, can I ask you to tell me what that one would be? You got 6 for AES. Let's see. So, I can pick either of these 2 x's, right? If I pick this x, then I must pick this x, and I have 2 choices here. So that would be 2 ways to do it with that x. Or I could pick this x, in which case I have 1, 2, 3, 4 ways to pick x's on rows 2 and 5. So that's a total of 6 ways to do it. Alright? So 6. Okay, good. How about, let's see, AGJ. Yeah, 0, right? Because with the G and the J, you have to choose these x's, which means in the first row, you don't, the x's are in those positions, so you can't choose them again. That would be 0. AGS. How many would there be for AGGS? 2, right? Okay. How about AJS? Also 2. How about EGJ? 4. EGJ, let's look at it again. Have to pick this one and this one. So then only 1, right? Only 1? Alright. How about EGS?
4.
Yeah, that looks like 4. Whenever the S is in there, we get a lot, because the X's for the S row are in different columns than the other one. EJS. It's going to be 2, right? And GJS is also 2. So add all that up, what do we get? Yeah, it's 21 again. That is just a coincidence. That does not usually happen. It's a pattern. Okay. R4. So R4, I've got, oh, so by the way, before I go any further, I've got to now add, or subtract, this is going to be subtracted now, minus 21 times 2 factorial. Now I'm doing the R4 times 1 factorial. So for R4, the good thing about R4 is there's only 5 terms. So you'll have AEGJ, AEGS, you'll have AEJS, and then you'll have AGJS, and then EGJS. Now, notice that any term that has A, G, and J together, look, A, G, and J, you can take advantage of this. It was 0 originally. If you add another row to the considerations, it's still 0. So I already know without even looking at my chart again that this one's going to be 0 because I got A, G.